Assume the period is 365 days. Sketch the temperature as a function of time. Okay, so that's the first thing we're going to do. So now notice that the horizontal axis should be denoted as T, meaning T as in days. Okay, and the vertical axis should be denoted as temperature, capital T. So temperature will be as a function of time, right? So the vertical axis will be as a function of the horizontal axis values. All right, so now let's label the numbers that we're going to need, okay? So we're talking about basically 1 year, which is 365 days. So we're going to label the numbers in the horizontal axis in the increments of 30 for each box, right? So this will be 90. Okay, this is going to be 180. This is going to be 210. Oh, not 210. 270, I meant. Okay, this is going to be 300 and so plus 90, that's 360. Okay, so now the vertical axis I'm going to label with numbers that make sense with the given temperatures. Okay, so every 5, let's label at 10 degrees. So this will be 20, and this will be 30, right? So for easy visibility, right? You know that the maximum is 33, so we're going to be fine. Okay, so now let's plot the first point. So it says January 15th is 33 degrees, right? So we know this is 30, so half of that will be 15. And that's given as 33 degrees. So let's find that. So 15 is half of this, 33 degrees. So we know that's 22, 24, 26, 28, 30, 30, 33 is just above that. So that would be somewhere here. All right, now July 16, day 197. Now where's 197? We know halfway, so we know this is 210. And 195 is right between that. So 197 is about that. It's about half the distance between these two. And that's given as 9 degrees, right? This is 8 degrees, so 9 is right in the middle between that. And again, this is 210, so half of that, and then half here. So we're basically talking about somewhere here, okay? And that's the minimum, right? That's the lowest temperature achieved on July 16th. All right, and notice it makes sense because in the southern hemisphere, it's the opposite of what you're used to seeing in the northern hemisphere if you live in the northern parts of the world. Because during the summer of the northern parts, the southern hemisphere is experiencing colder temperatures. Okay, all right, so that's 9. So now we need to figure out when the next high point is going to be. All right, when the next high point is going to be. So we're just going to have to also find the equation of this line, and that will help us figure out, you know, the period. But we'll have, however, actually, we know that the period is 365 days, right? So we can just, I guess, add, subtract, this is the 15th day. Okay, well, actually, the 15th day is the first day at which the max occurs, right? So that means we have to subtract from 197 the 15th, so that's going to be 182, right? So that means half the period is going to be 182. All right, so that means if you add 197 plus 182, you're going to find your day at 379 day, right? So 379. Or you can just add 365 to that, to the 15th day, and you will be at 380, 379, right? That's ballpark estimate. So let's say that we know that this is 390, so 380 is about there, right? So I would say it's closer, of course, to this 390. So it's going to be again back here somewhere. Okay. All right. So now we know that it looks like a cosine function to me because we're starting from the highest, we're descending, and then we're going back up again. All right. So now let's find the equation of this line, and also we're going to we can just connect this curve that we have. It's not going to be an exact curve, but basically the idea is to connect these points to form a cosine full wave of that, right? So now, how do we find the equation? First, let's write the theoretical equation. The t as a function of the cosine and all the constants should look like this. The amplitude cosine b x, instead of x, of course, we're going to use the t because that's the horizontal axis. It serves the same purpose as the x. T minus c plus d. So the constant in this case are a, b, c, and d. And the t is the horizontal independent variable, the time and days. All right, so now that we do that, let's find the absolute value of the amplitude. And why absolute value? Because sometimes the cosines and sines open upside down, right? So we want to just find the absolute distance from the highest to the midline, okay? And that's going to be the absolute distance of the amplitude. So how do we do that? We're just going to do the highest temperature, right, 33 degrees, minus the lowest temperature. And that should be divided by 2 to find the amplitude distance, which is exactly half, right, half of that range. So we're going to divide it by 2. And what we get is 24 over 2, which is 12, right? So notice the true value of A is also positive 12 because we're opening normally, right? It's the cosine's opening up, right? It has the standard orientation, so we don't need to make this negative, okay? All right, so now that we found that, let's find and solve for B. Now, how do we solve for B? We're going to use the fact that a normal period of a parent cosine function is 2 pi. So we're going to divide that 2 pi by that b value and set it equal to the true period of this problem. In this problem, the period is 365, right? So now if you solve for b, you're just going to have to do 2 pi divided by 365, and that's going to be your b value. Just algebraic manipulation. Right. And now the c value, let's solve that. What is the c value going to be? So notice first of all that the parent cosine function begins on the vertical axis, right? So that maximum value that you see would be located on the vertical axis. In this case, however, it is shifted to the right, right? So c is responsible for the horizontal shift. And how much is it shifted? It's shifted by the number of days, right? It's going to be the 15th day and not the first day, right? So we have to make that 15 in order to account for the shift so that the max value doesn't start from the vertical axis temperature. Right, now, how do we find the d value, the vertical shift? We know that the midline of a parent cosine function is at the t-axis when the temperature would be 0. However, here it's being shifted. And how do we find that? How do we find that value? Well, we know that we can just subtract 12 from 33, right? We know the highest point, and if we subtract 12 from that, the amplitude, we will be right at the midline, right? Because the midline, from the midline to either the max point or the low point, is exactly the amplitude distance, right? So if we subtract that amplitude distance from the highest point, we will be right at the midline, right? And that will show us the distance from the t-axis to that midline, and that will be the d. That's going to be 21, okay? So 21 would be somewhere, let's see where that is. So that would be 22, so right in the middle. That would be the midline. And from this midline to the highest point is an amplitude, which we figured out was 12, okay? So we found all the components. So now we can write this equation down. So it's going to be 12 cosine. The b is 2 pi over 365. 365, parentheses, t minus, what is the c value? 15, and then plus 21. Okay. Okay, so now we're ready to answer more questions. This says, what is the temperature on Mother's Day, May 10th? All right, so May 10th, let's figure out what day that is. May 10th is, so let's figure out what t-value that is. So we know 31 days in January, 28 days in February, because the period is 365, so we assume it's not a leap year, so February has 28 days in a non-leap year, in a regular year, right? That 3 out of 4 years are 28 February, 28 days of February years. Right, so now we know 31 days in March, 30 days in April. So let's see. So May 10, that's 10 days in May, right? So we add 10 more to that and see how much that is. That's going to be exactly 130. All right, so the t-value is 130. So we're going to plug in that t-value inside the function that we found to find the temperature. All right, so it's going to be cosine 2 pi over 365 times 130. Let's label it in green. 130 minus 15 plus 21. So what is that giving us? That gives us cosine 2 pi out of 365. Okay, what is this going to be? That's going to be 115 plus 21, okay? So you're going to do this in your calculator. You're going to be in the radian mode, of course. In the radian mode, you find this angle measure. Notice that this is the complete angle measure for that cosine, right? This part here. So find that, multiply 115 by 2 pi, divided by 365, set it equal, then find the cosine, make sure you're in radian mode, find the cosine. That result should be multiplied by 12, the amplitude, and then that result should be added to 21. So if you do this right, and you round to the nearest tenth, you should get 16.2 degrees Celsius. All right, graphically, let's see if that would make sense here. So 130 days, where is that? That's 120, and that's 150. So 130 would be a third of the way, right? So that would be, let's say, here. Notice it makes sense with the 16. I didn't draw the graph exactly, but the ballpark estimate is kind of there because it's less than, this is about 16.2. Okay, notice I drew this a little bit kind of curvy here. It should have been more straight. So 16 would make sense with where we are, right? Because this should be this should be 130, right? So that would be, let's say, here. All right, so 16 would be there, but once again, I drew this a little bit fatter than usual on this end, and probably this one as well. But in any case, the answer makes sense, right? Because it should be above 10 degrees. Okay, so now the next part, it says, this is going to be a tougher part. It says, give the dates during a 1-year period when the temperature is below 18 degrees Celsius. All right, so between 18 degrees Celsius. And again, let's look at the graph for a second and think about it. This is 18. So below 18, we're talking about basically this period. All right, we're going to talk about this period. So about from, I don't know, the 90th day or something like that, or probably above that, above the 90, right? Somewhere in the hundreds. And before 300, right? Less than 300 would be your upper limit. Okay, so we're gonna have to use algebra to find exactly the dates, right? But this is the idea. This is going to be the chunk of time between 100 and 300 that you will have to find algebraically, right? How do you do this? How do you do this thing? Well, you have to set 12 cosine of 2 pi over 365 times t minus 15 plus 21 being less than 18. Right? So you're setting the temperature function to be less than 18 degrees, right? Because you want to find the t-values accounting for that constraint, for that inequality. All right, so now if you solve for t here, you're going to have to subtract 21 from 18, and then you're going to have to divide that by 12, right? So what that means is that the cosine of 2 pi over 365 times t minus 15 would be less than negative 1 over 4. All right, so basically, again, you subtract 21 from 18, you get negative 3. Then divide by 12, so you're going to get negative 3/12. That's the same thing as negative 1/4, right? So that's how you get this result. Okay, now it's going to be interesting because we have to understand the unit circle here. So notice that your t values basically what you're going to have, you're going to have to get rid of this cosine. All right, how to get rid of this cosine is not by dividing by that, of course, but you're going to have to take the arc cosine, the inverse cosine function of both sides of the inequality. So that means basically that you're going to have 2 pi of 365 times t minus 15 less than arc cosine, right? You don't see the arc cosine here because that gets rid of the cosine. But on the right side, you will see that because you're taking that of both sides. Inverse cosine of negative 1 over 4. Okay? So now here's the thing though. Your calculator, if you try to find the angle whose cosine is negative 1 over 4, find the inverse cosine. Negative 1 over 4 is going to be a quarter of the radius 1 in the unit circle, right? Because that's a quarter but a negative. We know cosine is negative in quadrant 2 and 3, right? So your calculator will give you either this answer or that answer. Most likely it will give you this answer first because it likes to give the closest to the starting point 0 but positive, right? Unless the negative is closer, right? In this case, the negative and positive are the same distance from the beginning. So I assume that the calculator will give you something like this, t1. All right. So basically there are 2 times, like we said. This is the second time. So we're interested to find this chunk of time in the unit circle, right? That corresponds to the chunk of time in the t-axis here that we need to find, right? From here to here. All right, so now how do we do this? Notice that here you don't see 2 angles yet. You only see 1 angle, right, in that constraint. How do we find the second angle and find the combined inequality that uses 2 angles at the same time? Notice that this is actually the first value as we determined, right? So that means it has to be actually on the left side as the leftmost limit of this constraint here and not the rightmost, right? Because we're starting from here and we're progressing to a higher angle. So this should be a lower angle, the lower angle, and the higher angle should be the T2, right? So we have to switch that places and understand what's going to be on the upper angle. So we're going to move this to the lower angle, our cosine of negative 1 over 4, because the calculator will give you this position, right? That's going to be this. And that's going to be less than, so you want to surround that. You want to surround that with 2 different angles, right, in order to solve for this chunk. Okay? So that's going to be 365 t minus 15 less than, and how do you find the upper angle, this T2 value? Well, you're going to use a powerful formula. You know the fact that cosine of x is equal to cosine of 2 pi minus x. That's a very powerful formula. It gives you a chance to find the second angle whose cosine is going to be the same value, right? So you know that the cosine of these two angles is going to be the same, right? So this formula will let you find the second angle such that the cosine of it will be the same as the first angle. Okay, so you have to subtract that angle first angle, from the 2 pi. So that means this is the angle instead of that x here, the arc cosine of negative 1/4. You subtract this angle from 2 pi, and that's exactly what you should do. right? So it's going to be 2 pi minus our cosine of -1/4. Okay, so now that we have that, we can simultaneously solve this inequality. It's a combined inequality for t, and then we will find our constraints. The leftmost t value, right, the beginning of that time at which the temperature is less than 18, and the ending of that time, right, the upper limit for that time, for that day there, that is the last day at which the temperature is below 18 degrees. All right, so once we solve this. So how do we do this? First, you're going to multiply both sides by 365, right? So what you're going to get is 365. And also you're going to divide by 2 pi, right? So you're going to get rid of this at the same time, multiplying both sides by this reciprocal, right? So 365 divided by 2 pi, our cosine of -1/4, less than, and we got rid of it, so we can just write t minus 15 now, less than, and this thing, be careful that it has to be multiplied. Let me erase this so that we're not distracted by it. That's the t2. I'm just going to write it small here, t2. Okay, so you're going to have to multiply this reciprocal to this whole expression that has two terms, right? So it's going to be 365 divided by 2 pi. Let's use brackets because this is huge. 2 pi minus the arc cosine of -1/4. Okay, so now that we have that, of course you're going to add 15. So it's going to be what? It's going to be actually crazy because you're going to have to add 15 to both sides, and that's going to be even longer. So I'm going to write it here. So you're going to have 365 over 2 pi, our cosine of -1/4, plus 15 is less than t is less than 365 over 2 pi, being multiplied by 2 pi minus our cosine of -1/4. And of course, after that bracket ends, you're going to have to add that 15, right? Because you added it to both sides of the inequality, right? So now that we have that, you're going to use your calculator very, very carefully for these two sides to find the constraints for that, the upper and lower limits for that time, for the t. So you're going to have to be in the radian mode. Be careful that you're in the radian mode because everything is in terms of pi there. Okay, so you're going to have to find the arc cosine of -1/4 in radian mode, multiply it by 365, divide that by the product of 2 pi. Then that result should be added to 15. So what you should have on the left limit, the lower limit should give you about 120.9 is less than t is less than, and this one is going to be harder to do on the calculator, but you have to first find the arc cosine. Be sure you stay in the radian mode. If you're not, just correct it. Make sure you're not in degrees, otherwise you're going to get wrong answer. So arc cosine -1/4, negate that answer, and then add that to the product of 2 pi. And then that result inside this bracket multiplied by 365 divided by the product of 2 pi, then that result should be added to 15. And if you do this correctly, you should yield 274.07. Now, what does that mean? Notice these are not whole numbers, so we should be very careful. We can't say 120 days, right? We can't say 120 days. We have to round it to the next day here, so it's going to be 121, right? Because the next day hasn't arrived yet. So we're going to do 121, the t, 274. And we're rounding this down because just to make sure that the t is included, that the upper limits, whole numbers are included, okay? All right, because we can't assume 120th day because, you know, most of that day and, you know, most of that day will be, you know, used up. I mean, if you want, you could really write 120 days if you wanted, but I prefer just to make sure that everything is rounded to the nearest whole number. In this case, it's 121 and 274. It's not going to be wrong if you're just off one day or somebody's going to question you about that. right? So basically between, starting from the 121st day until 274th day, right? So what does that mean? So let's find what the days are. So when the t is 121, that's precisely May 1st, right? As we figured it out, because May 10th was 130, right? You subtract 9 days, you get May 1st, so that's exactly 121. 130 minus 9 is 124. 121. And now the next one is 274, right? And what is that? That's going to be October 1st. Okay, it's going to be October 1st. If you want, you can count that. You're going to see that it's going to be true. So now what does that mean? That means our temperature is below 18 degrees Celsius from May 1st to October 1st. So thank you so much for watching this, and I'll see you in my other videos.